All right, welcome to the presentation on Know Your Java. My name is Venkat Subramaniam. Thank you so much for joining. Let's talk a little bit about what we're going to do here today, and then we'll get going. We're going to look at a few things that we, as programmers using Java, may have come across, but can surprise us sometimes. I call some of these as stub your toes kind of problems. I don't know which one hurts more for me, when I stub my own toes or when I watch others stub their toes. And here are a few things I've seen other people run into issues. I've run into a few myself, so I want to talk about those. But the way we're going to do this is fairly interactive. I'm going to show you a piece of code, and you're going to try to answer what you think the code is doing. Don't worry about it. You're not in an interview. You're not being judged. You're not being evaluated. You don't have to be right, and you're most welcome to talk to people around you. In fact, I encourage you, I want to hear some noise in the room, so do talk to the person next to you, ask what they think and what you think, and compare notes, and then we'll move forward. So are you ready? All right, let's do it. Well, we'll do a quick warm-up to begin with. Awesome, thank you. So we'll do a quick warm-up to begin with. This is not a technical question, but could be as hard because it's going to reach into your memory for that. So here comes the very first question. In total, how many years have you used Java so far? This is just to warm up so we know you're able to connect to the QR code. And here is the QR code, so point away to it. I'm going to give you a couple of minutes to answer that. Shouldn't take that long. And then once you key in your response, we will take a look at what you said, and we'll move forward. And this is kind of what you're going to be doing along the way. Your responses are 100% anonymous, so nobody knows who's answering it. So don't worry about saying what you feel. You're not being judged. You're not being evaluated. So here we go. Let's see what your response was in this particular case. So we had 97 responses. Thank you so much for that. And we had less than about 23% of us said less than 10 years, and about 25% of us said more than 10 years, and the pretty vast number of us said more than 20 years. That's awesome to see the experience in this room. But again, there's always these outliers are just liars. And those who said more than 30 years, Java just turned 30. So it cannot be more than 30 years, unless, of course, you are working on developing Java before it was released. Then, of course, you have my deepest respect for that. Thank you for doing it. So awesome. So that's a good response. 100 responses so far. That's great. Let's keep that momentum going. So let's get to the technical part in here. Before I jump into the first example, I want to say a couple of things. I'm a huge fan of statically typed languages because they give us early warning, early errors when things are going to go bad. I'm also a huge fan of automated testing. I do follow quite a bit of automated testing in the code I write. But most of the examples I'm going to show you here, your compilers will not catch you. And almost all of them, well, okay, maybe half of them, your unit test will not catch you. So as much as I love compiler checking, and as much as I love automated testing, these are the few things that we need to really know, otherwise it can hurt us. So let's get to the very first one. And before I show this example, I want to quickly say my intention is not to point fingers at anybody. I often say we live in a very unfair world. Java is being used by 10 million programmers or maybe more. And I often say when they make a mistake, 10 million people know about it. It's a very unfair world because when I make a mistake, exactly 3 people know about it, my wife and my 2 kids. And so it's very unfair that their mistakes are more visible than mine, but I tend to make more mistakes than they do. But I want to start with one thing that we can learn from in terms of API design, and that's my real intention, but not to point any fingers at anyone. So let's start with our very first example here, just to get a feel for it. And so here is my first code example that I want to point to you. And in this code example, what I have here is a list of numbers is equal to array list of numbers 1, 2, and 3. And I print out the numbers, and in this case, the result is 1, 2, and 3, as you can see from the output. So the result is 1, 2, 3. And then I say remove 1, and the result is 1 and 3 in the output, as you can see. So that is the code we see in front of us. The question to you is, what if I were to modify that list to a collection like so? So what's going to be the difference when we make that one change is the question, right? So that's the question we want to answer, and I'm going to clear that a little bit so you can see that a little bit better. So here comes the QR code for you to point to. So there you go, and take a stab at it. You are most welcome to talk to the people around you. In fact, I encourage you to talk to the person next to you. If you want to call a friend, that's perfectly fine as well. So do chat. Drag yourselves closer to another person if you want to talk to them. Don't hesitate. I want to hear some noise in the room, so go ahead and chat about it. All right, I think most people responded. Time for us to take a look at the responses, can we? All right, so let's take a look at what the responses were. So this one is going to be, 92 responses, awesome. And about 33% of us said 1 and 3 as the response. About 12.8% said, I think I should give a clap to those people. I love your honesty. I love those words, I don't know. I wish more people can actually bravely say that, right? So I don't know is an amazing response. In fact, I would say that 12% has the chance of getting it right 100% of the time, right? So that's awesome. So my respects to you, honestly. And then about a little small percentage, that was about 2% of us said 1, 2, and 52% of us said 2 and 3 as the response. Awesome. So let's go ahead and run the code and see what the response is. It is 2 and 3. So what just happened here? So about half of us got it right, which is why it's really troubling as well to think about it, isn't it? So essentially in this case, you had a list to begin with, and when you called remove with a 1, it really removed the value at the index 1. But unfortunately, though, when you use the collection, there is a function called remove, which takes an object, and there was an auto-boxing, in this case, auto-boxing of 1 to an object integer in this particular case. So it got rid of the 1, and so you were left with 2 and 3. But what is the lesson we can learn from this? Now we can agree that designing APIs are really, really hard. It's incredibly difficult to get it right, so we need to really have a respect for that. But in this case, there are a few things we can also take home and learn, so we can learn from these experiences as well. And that is, I often say code, I would say, a code should reveal its intention. So it would have been a lot better to call the int, remove with the index, right? So this is an index, have called as remove at index. So that would really remove the ambiguity. And also there's another lesson to think about in here. When you're using inheritance, when you have a type differences, it usually leads to more trouble because you're trying to override and you are conflicting with overloading at the same time. And unless you do it really well, the chances are you're going to get it wrong. But in all fairness, though, this is not really a big problem in this case, except in the case of an edge case, just to underline that. If you use any other list of types, you wouldn't run into problem. This was an edge case in all fairness because it so turns out integer can be auto-boxed to an object. It can also serve as an index. So in a way, it's a bit unfair example, but nevertheless, it's a lesson we can learn from, but also to know that, I'm sure you all have faced this problem, right? Code always does what you type and not what you mean. It's very frustrating when that happens. But this is an example where the code literally did what you typed, probably not what you meant. So this is why it's important to do some testing as well and make sure as we evolve the code and make changes to it, the code is still working as expected. Now, continuing a little further on this one, I want to give you one more example. And before I jump into this next example, I again want to point out I'm a huge fan of the idea of type inference. I love type inference. I use it quite extensively. Now, having said that, there are times when a type inference may not be a right choice to use, and that's what I want to focus on in this particular exercise. So let's take a look at the code in here. So you can see that I have a collection of numbers, as you can see in this example. So I've run the code. It says 1, 2, 3, and 2 and 3 as the output. So the question really here is, what if I were to change this collection of integers into a var to use a type inference, right? So that's basically the change we are making in this code. I'm modifying this from a collection into using a var, and the question is, what's going to be the effect of this? Ready? All right, so here we go, and let's take a look at it and see what our response is for that question. Again, it's perfectly okay to talk to people around you, to call a friend, whatever you need to do, that's perfectly fine. So don't hesitate. All right, I think we should look at the response then. So let's jump over to see what we saw in here. So this is on type inference. So 20% of us said 2, 3. About 70% of us said 1, 3. About 10% of us said, my stomach hurts. Okay. And I think nobody picked up the other option in there. Awesome. So, beautiful. Once again, there is about 30% of us who couldn't decide in this case, right? So let's go over here, run the code, and see what it tells us. So when I run the code, you can see the result is 1, 3. So if you got that response, you got it right. But here is an example of something to think about. Like I mentioned earlier, I'm a huge fan of type inference. I love it. However, be very careful using type inference. Type inference, as the name alludes to, infers the type based on the context. So it can only work with what it knows. It does a thorough job of determining it. But the thorough job still is limited to what it can find in the surrounding. So in this case, if your intention was to make numbers a collection, that's going to be fail in this case because the type inference only knows that it is an array list. So this is even worse than the previous code we may have had. So numbers, rather than being collection or, in this particular case, you could say list, it ends up in this case being an array list. So the question you want to really ask when you use type inference is that the type you really want it to be? But the good news is most of the time you can hover your mouse over the variable and IDEs will tell you what the type is. And if it is not the type you really expected it to be, well, then don't use type inference at that place. So you want to really ask the question and take time to understand when it is a good time to use type inference, when it's not a good time. And of course, some people will tell you it's never a good time. I politely disagree with them. In fact, this is kind of the funny thing. In the amazing Java user group in Dallas called me to come and give a talk a few years ago. I totally forgot what talk I decided to give until the night before I looked up, and my talk was going to be on type inference. And I was in a bit of a panic. I can speak about type inference for 10 seconds, but the talk was scheduled for 90 minutes. I was kind of wondering, what am I going to do for the remaining time after the 10 seconds? I can say, Java has type inference. Thanks for coming for my talk. So I was like, what do I do? The talk did not go for 90 minutes. It went for 120 minutes. And 2 hours later, people refused to leave the room. The right side was haters of type inference. The left side was the lovers of it, and fight was going to break out. How do you tell the cops you're in a bar fight without being in a bar, right? So this is the beauty of type inferences. There are people who love it. There are people who hate it. You kind of know what camp I belong to. I belong to the camp of I love type inference. But just because you like it doesn't mean you use it all the time. We got to use caution and determine when it's a right thing to do and when it's not a right thing to do. Now, I mentioned about a few things we need to be careful about. And I mentioned earlier that the unfair world we live in is if I make a mistake, 3 people know about it. Well, this one is an exception. There was a 4th person who knew about it. So when I wrote the first edition of functional programming in Java, somebody extremely polite, rather than posting on social media saying, this guy's an idiot, took the time to write the email to me saying you're an idiot. So that I really love when people do that, right? No, actually, the person was more polite than that. I'm just joking. But she took the time to point out to me that I made a mistake genuinely in the book. And in the book, I have made a claim about arrays.as list, which was my mistake. And now I realize this is why we write 2nd edition of books. And we did publish the 2nd edition of functional programming in Java, and I corrected these mistakes. The reason being, you correct all the mistakes in 1st edition, so you can make newer mistakes in the 2nd edition, isn't it? So now that we have that out of the way, let's talk about this code. What mistake did I make? Let's talk about my own mistake in here. So here's a piece of code for you. I have created an arrays.as list with values 1, 2, and 3. Now that I have values 1, 2, and 3, I'm going to add a 4 to this collection. If that succeeded, you're going to quietly move forward. If that failed, you will print add unsupported. Then I call a set. If that succeeded, you quietly move forward. If that failed, you print set unsupported. Then finally, we print all the numbers left in the collection. So the question to you, if you choose to accept it, is to talk about what is going to be the output of this particular code. Is it going to be add unsupported, set unsupported? Or is it add unsupported only? Or is it set unsupported only? Or is it going to be neither of them? There are only 4 options, right? So let's talk about which of those options it's going to be. So here you go. Let's point your cameras at it, take a stab at it, and then we'll see what our response was in this case. All right, let's take a look at the responses so far for this. So what did we all decide? So this is on the arrays.as list. We had a 99 response. Something tells me we're not in a democracy to make a decision on this one, right? So nevertheless, that couldn't have been more divided in terms of the responses. Oh, we have 103 responses. I don't think it tilted that very much. So we have about 32% of us said add unsupported, set unsupported, meaning both of them are not allowed. About 20% of us said set unsupported, and 23% of us said that add is unsupported, and about 31% said no errors, it's going to be 1, 2, 2, 4. Now, you know why I really don't like arrays as list. But at the same time, I do have to tell you one thing. While the correct response is really that 24%, the other 75% in the room are really the kindest people in the room. They know the answer, but they gave the response just to make me feel better, right? They said, it's okay, Venkat, you're not the only one who can make this mistake. We are with you. So my hugs to you. Thank you for, being kind to me. Well, absolutely, it's hard to understand what the code is going to do. And I was misguided by this as well, because I looked at a symptom, and like everybody else making mistakes, I made the same mistake to generalize and assume it until this kind person emailed me and said, dude, you're wrong in your book. And so what mistake did I make? Well, the mistake I made was an arrays.as list creates an array that's not expandable. So you cannot add to this collection, so the add will fail. Sadly, though, you're not expanding when you set into it. So as a result, you get add unsupported, but it doesn't tell you you cannot perform the set. So this is where I was wrong. I assumed this is immutable. It's not. So I have a recommendation to you, and you got to do this right away. You cannot wait for tomorrow, and that is quit using as list, right? Because it fooled me. It doesn't deserve its existence, right? So as list should be banned. It should be deprecated, in my opinion. But jokes aside, I have a better recommendation. It is way better to use list of as we move forward. So list of was introduced in Java 9, and this is my new friend in all purposes. Let's see why in just a minute. If I were to go ahead and output right here, I'm going to say this is numbers. Look at the type of the numbers that you're going to see in this case. I'm going to say get class to find the type of it. Notice it's arrays, $array list. That's what you have. But what I'm going to do, though, is to modify that to use a list of, as you can see right there. But when I use a list of, you get both unsupported, add unsupported, and set unsupported. But also notice the type is actually an immutable collections, and that is way better. So my recommendation is, use, list of, set of, map of, and so on, if you want to create a truly, I would say, immutable collections. So anytime you want to work with creating some sample data or some data within your code, or even your test cases, I would argue this one is a lot better. So I've been converting most of my code to use list of and things like set of than using things like as list, and that's what I would recommend. Moving forward is to use those as much as you can, and those are truly immutable. Similarly, when you look at the Stream API, way back we had a collections.toList. But then we had in Java 12 a collections.toUnmodifiable list. But more recently, you have a toList directly on the stream. The difference is the collectors.toList creates a mutable list, but the stream.toList creates an immutable list. So even though the names are the same, what they return is different. So it's important to pay attention to what they actually create so we can benefit from them as well. Great. Now I talked about my mistakes so far, but let me change and talk about a different example. This is an email I got from somebody. I get emails, multiple emails every week, and I'm very delighted for that. But occasionally, an email kind of makes it to a talk like this. And this one was an email from somebody. I cannot mention the name of the person or the company, but if it will make you any more comfortable, I will say that everyone's 401k plan and pension plan is with this company. So there you go. So this gentleman had a code where he pulls a customer with a lot of wealth. So they have a lot of different accounts with them. And then goes through a stream and performs a certain operations on every single one of those accounts, only to create a resulting account. And then after creating the resulting account, puts it back into a collection. And the person's email said to me, "Hey, Venkat, I have had this code for a while. It worked fine until this morning. And I made one change this morning, and all hell broke loose. What am I doing wrong?" So that was the question. And thankfully, it didn't take a whole lot of time for me to find the problem, because it's something I've been telling people not to do. But before I even go that route, let me just emphasize it. This is the problem I see with a lot of us. I've told thousands of people over and over and over, don't do this. And I'll show you what that is in a few minutes. But you should have seen my shock, honestly. One morning, I open up a source code on a code base only I maintain. There is no other developer touching this code. And shockingly, the code I've been telling people not to write is right there in my own code base. Now, to be fair, I did leave the window open the previous night. Who knows what alien came and wrote that code, right? But the point I'm making is, you may know not to do it, and yet it can slip through in your code like it did in mine, so we got to be more vigilant about this. So what is the problem? Obviously, I don't want to use stocks and all of that, so I distilled this to a very small example so we can actually see the problem here in front of us. So here is a collection of names that you see in here. And given this collection of names, I have in uppercase, oh, by the way, this is a code with a problem. Keep that in mind. So I have a collection of names I created in uppercase. I loop through the stream. I perform the map to convert to an uppercase. Then I call the for each, and I add this to that collection. And then I print the size before and after. And as you can see, the result is a 7 and a 7. So the code works, you may say. So my question is, what could possibly go wrong in this code, right? So the gentleman who sent me the code, which was obviously dealing with mutual funds and funds, but what change would this person have made to break things? And along the way, I will mention one more thing, but after we answer the question to this particular code. So here is your URL to answer that question. So what could possibly go wrong with this code? So let's see how our respondents are able to do for this one. All right, we are ready, aren't we? Okay, so let's take a look at what our response was for this. So this one, we had about 94 responses, awesome. 43% of us said the lambda passed to for each has side effect. You nailed it. 30% of us said the lambda passed to for each should be a method reference that has no consequence actually. 22% of us said, I have a bad feeling, I love it. And about 7% of us said, nothing, it's beautiful the way God created. So let's talk about what could possibly go wrong in this code. Now, before I go into it, my first question, let's focus on this line of code. And honestly, if you would please, how many of us in this room have seen a code similar to that in your own code bases? The hands go up, right? And I keep my hand open as well because I just told you I was guilty of this myself, right? And so we have seen the code like this. Now here's the problem. I call this the ticking time bomb. The person who wrote this code probably quit 6 months ago, and they have left a ticking time bomb. At 2 a.m., your code is suddenly going to misbehave because it's not going to be deterministic. So what did this programmer do on that fateful day? This person was extremely lucky. So I have a new saying, forget works on my machine. This is no longer the most important slogan. I love to hear it failed on my machine. The reason I say that is, if you are very lucky, the code fails on your machine. If not, it waits for time in production. So this is why I say this developer was extremely lucky. The reason I say he was lucky is he made that one change that morning and saw the code fail on his machine. Imagine the consequence for this developer. Had it not failed on his machine, you cannot have unit tested your way out of it. This person puts it in production, and there's a little ticking time bomb in production. You don't know when customers are going to lose their accounts. And imagine you get a call saying, what just happened? We got calls from customers saying they did this transaction, and their accounts are gone. and how do you really respond to it, right? So what is wrong with this code? So let's go back to this code and make that one change that might really affect it. So I'm going to modify that one line of code and change it to parallel stream, which is what that person actually had done that particular morning. Now, did you notice that? It said 7 and 7. And you tell Venkat, what's your problem? It works. I don't use the word it works anymore. I use the word the code behaves. That's all it does. And it behaves nicely sometimes and doesn't other times. But if you take this code for a minute, and I'm going to simply say run Java right now on the command prompt, and I'm going to run this a few times, I make no guarantees here because it really depends on what the demo guards are thinking about me today. If they want to work with me or not, I cannot guarantee that for you. Ooh, did you see that? So, yeah. So there are times when the code misbehaves. There are times when it misbehaves differently. So that's one of the problems. Would you like a 5 or would you like a 6 today? So the point is that there are elements being lost in this particular computation, but why? Because, as you rightly pointed out, the code has side effect. So the moral of the story is the following. So imagine this happens in development, and this happens 6 months later in production. It not only happens in production, but it happens when you are on call. That's my problem oftentimes, right? I don't care it fails, not when I'm on call, right? And that's when your phone rings at 2 in the morning, 2 in the night on that Wednesday, and you're like, I got to go to work. Why? Because a stupid code is not working again, right? This is the ticking bomb I don't want to be really maintaining in my application. That can be scary. So what really went wrong? The problem here is this lambda, you can say, is not pure. So I'm going to spend the next about 8 minutes expanding on that one so we can keep this in mind. Because this is a very common problem I see. And if there's one thing, if you will, please, you can take from this talk is to go back, and those who raised your hand is to go back and attack that code and refactor it. And those who didn't raise the hand, the chances are you still have that and you don't know about it. So take a look at that as well. So what is wrong with this? The first thing I want to say here is lambdas have to be pure. Because if they're not pure, you're going to be in trouble one day when somebody turns into parallel or relies on lazy evaluation. But what is a pure function? I want to ask that question. A pure function is idempotent. It returns the same result for the same input, no matter how many times, right? How many times you can say it is called. So essentially, it has no side effects. But I want to summarize this. Most people, I would say qualities of a pure function. And I'm going to give you 2 qualities, and most people will tell you right away, well, duh, it's obvious. Well, yes, most people will tell you the first one is obvious. But I bet you most developers have not thought about the second one I will mention here as well. But the point here is not one, but both of those are highly essential. So what are those qualities? The first quality is a pure function, you can say, a function does not modify anything outside. So essentially, that's a very first thing. Now, I want to emphasize this. When people look at a piece of code, they say, oh my gosh, you're mutating, it's not pure function. Like, time out. It's okay to mutate stuff. It's perfectly okay to mutate stuff. Mutating is like changing clothes. Everyone here, I bet, has changed their clothes, right? If not, nobody would be sitting near you. It's going to be stinking. It's okay. It's a must to change clothes. The only thing we ask you is, please don't do that in public. That's exactly the point. Mutation is like changing clothes. Yes, please do it, but not in the visibility of others. So if you're mutating something within your function, if nobody can see it, there's nothing wrong with mutation. Do as much as you want to. But the mutation should not be visible outside, so that a pure function does not modify anything outside or to be visible outside. That is the key. That's rule number one. I think most people in the room will say, well, obviously that's the case. We know it. But rule number two, a lot of us don't think about, but is as important. Rule one is necessary, but not sufficient. So the rule two is a pure function does not depend on anything outside that may possibly change. So this one is the one that gets us into more trouble oftentimes. So a pure function does not depend on anything outside that may possibly change. So it's important to be both ways for a pure function. So don't change anything outside, don't depend on anything outside that may possibly change as well, and we need to protect both of those in this particular case. So to illustrate this point, I'm going to bring one more example in the next few minutes so we can take a look at it really quickly and then move forward. So in this case, you saw the code was misbehaving, which is kind of scary, but here is my very last example that I want to show you on the streams. So let's take a look at this code example in here. So the question here is that I have a list of 1, 2, and 3, and I have a map where I'm accessing the factor 0, which has been set to 2 right here. Then I set the factor 0 to 0, and then I'm printing the result out. So that is the code. And my question to you, the last question for you here is the following. And that is, what is going to be the output of this code? So please take a look at it. And we'll wrap up with this particular question as the last one in here. Now, most of the examples I showed you here, your compilers don't catch you any one of them. Maybe some of them a unit test will catch, but not all of it. And like I mentioned earlier, this is either you know it or you don't. And like I said, these are the things that either I have stubbed my toes on or I've seen other people stub their toes on. And so these are all things I've seen in code where people have done these things. So it's a little bit scary when things can lead to those kinds of problems. We got to be careful about it as well. All right, then, let's take a look at what our response is for this one. So for this one, we have about 90 responses. About 8% of us said 1, 2, 3. About 62% of us said 0, 0, 0. And about 21% of us said 2, 4, and 6. And about 8% of us said, I have no clue, I want to go home. I like that response. I like to ask this question in interviews. If the person answers the question, they are fired already before they are hired. The reason I often ask people is that the code you want to write in production? I want maintainable code. I don't want puzzlers in my production code, right? So let's talk about what's wrong with this code. When I run this code, the result is 0, 0, 0, but that's because streams have lazy evaluation. And because of lazy evaluation, this change is not really used until this line of code is evaluated. This is basically an example of that rule number 2 I talked about. And what was the rule 2 of purity? The code should not depend on something outside that may possibly change. If you look at this code and ask the question, is that a pure function? If you only think of rule 1, you would say, yes, it is. But if you look at the rule number 2, you say, oh my gosh, no, this is not a pure function. And I would summarize this by saying this. And this is why, in functional programming, right, you could say programming, we emphasize immutability not because it is fashionable. This is not the reason for saying it, right? So, but why? I'm going to say you could say functional programming relies on lazy evaluation for efficiency. And you can say lazy evaluation in general and the parallel execution rely on purity of functions and immutability, immutability, you could say, for correctness. So this is why it's extremely important to be careful about purity of functions. It's not because, ooh, look cool, we are all geniuses, we can write immutable code and look cool about it. That's not the point. It's an existential crisis, if you will, for functional programming. If we violate purity of functions, the results are not going to be correct. What good is a beautiful code that produces wrong results after all, right? So this is one of the reasons why we honor purity of functions and we also honor the immutability is because functional programming relies on lazy evaluation for efficiency, and lazy evaluation and parallel execution rely on purity of functions and immutability for correctness, and that's the reason why we should be very careful about it. So we looked at a few different problems here. I'm sure there's a few more to look at, but often I say code is not what you see, but what you actually look at. You got to look deeper into the semantics of the code. Syntax is what you see, but semantics is what you should be looking at. And these are all semantical issues we should be really familiar with and keep looking at them to avoid issues. I thank you again for joining. I hope this was useful to you. I really appreciate it. Thank you.